Welcome, and today's meeting is on hash tables. So how to create and work with hash tables. Someone sent a message. Okay, the YouTube link will be available. I'm going to share it in the chat after the session. Let's get started. So what are hash tables? So as what I can say, a simple way to explain what hash tables are, um, you can see a hash table as a way to organize your data in a way it can be much easier to access the data. We've seen double linked list. These are some data type, some data structures where you have items and you can add items in this list. But sometimes when um, you can look through the list from the start to the end and look for items. But what if you want to search an item, let's say by name or by another value which is not an index, for example. Hash tables um, are good to implement for these kind of situations because the search time is more reduced, and also um, computing values like comparing the keys takes some computational power, and we tend to reduce those things on the hash table data structure. The first example we're going to start with, let's say we want to store some products. Let's say we have a database and we want to store in products. So we're going to start by defining the structures and see. I'm going to first start by creating our main header file, and inside the main header file, we make it double inclusion protected. So if the main is the main edge constant, macro constant is not defined, we define it. Then and if great. Here we have the main edge, and I want to include that in the main function, but let's start defining one certain structures. We're going to have one structure first here. I'm going to call it the product struct. So I'm going to call it like that, struct product. And also in the same time, I'm going to define a type. So type def product, and the type will be called product type. A product has a name and also has a price. So the name of a product, we can see it is a string. We can say it's a string. And the product also has a price. And the price, I'm gonna say price like that. Let's go back in our main function. And I'm going to include the header file here. Then declare our main function. For now, we don't intend to receive any arguments. I'm going to return 0. When you are working with data, you have to think of the best way to represent your data. And we see that we have some simple data types and some more composite data types like structs and other more complex data type, a group of data like list. So here we can define a table that contains a list of products, or we can store the products in a way that we can create new product and add them into a list. So depending on the way you want to store your data, you may want to add other field member to your struct. For example, here, if you want to store your products in a table, you don't need any other field to be added here. We can just declare a product table like that, products, and we can say 100 products. And then we can simply assign value to the different elements of this table. That's one way of doing it. So now, what if you want to, let's say, you don't know the number of products you have at the start of the program, but you want to add them dynamically while your program is running. Then you might say, hey, a table is too static. Let's choose another data structure. Then we say, okay, a list might be more convenient for this kind of situations. So we say, okay, we want to store our product into list or into a double linked list. So we have a simple structure here, product, which since we want to store it inside in a single linked list or a double linked list, we may want to add some additional fields in order to add those capabilities. So for us to be able to use it into or to add these product types into a list. There are some required fields for list, and let's say I'm going to call a field member for single double linked list. Okay, and those field member here we have structs, product, and the first field member I'm gonna call it underscore next, and the second field member I'm gonna call it underscore previews. So by convention, I'm going to say all fields that start with an underscore are not intended for direct access. These are private fields just for us to be able to organize these items inside a list. So we added a capability to the struct so that it can be used in a double linked list. Or what if you want to, let's say, be able to add other data structures capabilities you want. Let's say you want the product struct to be stored in something like a tree. Maybe you want to add some additional fields so that the struct can have the support for trees. For now, we only want the structure to support the double linked list. So let's create some functions to that will allow us to create a product. So here I'm going to add a function here named create product, or just name it new product. The new product function, we include the main header file, and also we include some libraries, the std because we're going to use some dynamic memory allocation. And our new product function should return a pointer, or a pointer, yes, a pointer to a new product. The fields for a product are the name and the price of the product. So we want to say name and also price. This function will create a new product. Product type P, gonna name it P, the variable, and call the malloc function. Size of product type. So if the memory allocation did not succeed, meaning that P equal null, that means we're going to return null. But if it succeeded, which means that we can set the different fields for our products. We have the product name. For the product name, we want to make a copy of the string, the name, because we don't want, let's say, when a function calls with uh, a name array, and later, for some kind of reason, the original strings get deleted from memory, that can cause a problem. So I'm going to, let's say, str dot. This is a function from the standard library named string.h. We pass in a string, and the string, it creates a copy of the string. We also want to set the price of the product. Next, we want to set the field next. So these fields are not, let's say, I can say they're not related to the product, but these are just additional fields for the product structure to support different data structures, and the kind of data structure we want to support with the next and the previous field is the double linked list data structure. We received some questions about PHP data structures, the PHP arrays. The same principles apply when you want to support different data structures. You add the fields related to that data structure. We know how to create a product. Now it's time to delete a product. The same thing, we include the main header file, include the standard library, delete, and the delete function receive a product type. If you look at how a product is created, there are certain fields we need to free up first. We need to free up the name field. So we call free on the name field. And after that, we free the product itself or the variable. Great. So we have ways to create a product. Now it's time to be able to add products in a list. So I'm going to create a variable in the main.c file and name it product. So the product, it will be called the product list. And I'm going to set it to null. So a product list start with so someone asked a question is why did we use the str function to in the new product function. I'm going to explain why, because we can kind of just say we can do something like that, but this is not advised. When you when another function called this new product function, it is going to pass in a string, and maybe these other functions need the same string somewhere else. So if the product struct is pointing to the same string, and while the parent the caller the function that passed in um, the original string, uh, maybe the first string is needed somewhere else in the program. So we want to make our own copy of that string. So the original string won't when modified, that would not affect uh, the, there is some noise. Okay, so we want to make a copy of the string so that the the field name of the product won't get affected if the original string get modified for some other reason in other part of the program. But I'm going to explain it. So this is why we use the str function to make our own copy, to make a copy of the name and pass it to the name field. The next thing is why we did not free the price field. The price field, we don't need to free it because it wasn't dynamically allocated. For example, when you want to duplicate a string, a new memory a dynamic allocation happens. So we allocate a new strings and copy the source string into that new string. So here a dynamic memory allocation happens. But here, this is just copying values, but there's no dynamic memory allocations. We don't need to free anything inside uh, the delete product function. We don't need to free up the price field. Now let's go back in the main function here. I'm just going to call this a list, and I'm going to include some libraries, a stdef library, because this macro is defined inside this library. So the list, as what we already know about arrays, the name of the arrays represent the first element in the array. The same thing goes for double linked list or single linked list. So the name of the list represents the first product in our case here. It is a pointer to a product, but for now, we don't have a product yet. So what we can do is to create some utility functions to add things to this list. I'm going to name it add product.c. So this will be the function to add a new product in the list. Let's include the main header file. And so when this function is called, it doesn't return anything. We pass in a list, and the type it will receive will be a pointer to a product. Then the name of the product, then the price of the product. Okay. So why do we pass in a pointer to a product? Because we want to be able to change the value stored inside this variable from within the add product function. A function cannot modify the value of a variable from another function unless it knows the address of the variable. So we want to pass in the address of this list variable. So this variable that represents, let's say, the first element in the list. So we want to pass in the address of that variable to the add product so it can modify its value. And next, the name and the price of the new product we want to add to the list. And that's it here. Then the next thing is to create a new product type, new product. Then we call our function named new product. Oh, I forgot to add the prototype inside the main header file. Let's go back and add those prototypes. Okay, so we already created the new product function. This will return a pointer to a new product. We pass in the name and the price. We also created a function called free product. So we pass in, let's say, delete product. We pass in the pointer to the product like that. And our new function called add product will just add a product to a list. To a list of products. Okay. Now we're good for that. I'm going to save the header file. Okay. So now we pass in the name of the product and we pass in the price of the product. So the return value here would be a pointer to a product. So that will be like that, new prod. So if the new prod is equal to null, or let's make it very simple, not new prod, that means something uh, something goes wrong. We cannot add the new product because we can't create it. So we want to return, let's say I'm going to return 0 to indicate that we weren't able to add a new product, which means we're going to change the prototype of this function to int add product. But if we successfully add a new product, which means we return 1, now it's time to add this new product to the list. I'm going to suppose that we want to add the product at the end of the list, or the most easier would be to add it at the start of the list, I guess. Let's just make things simple. I'm going to declare a variable named product type, and I'm going to say this is a cursor, and I'm going to set it to null. In order to use the null macro constant, we need to include a stdef library. Okay, I'm going to say, okay, the cursor start from the first element of the list. You can add some error checking conditions, but the focus is not on these on handling errors, but the focus on understanding how these data structures works. So we have the cursor. So if the cursor value is equal to null, it means that the list is empty. So if the list is empty, the first element of the list will be set to the new product. But before we add this in the list, we need to set the next and the previous fields. So how do we do that? I'm going to come in here. So if cursor, then that means new product next equal to cursor, and what else? And also cursor dot prev equal to new product. So here we're connecting the items in the list. Now the next step is, since the head of the list become the new inserted elements, then we can just say list equal to new product. I guess that's all for now. Um, if we don't even need to declare this list this cursor variable, but it's very, I think it's useful to have it here. It makes the code more readable, I think. Okay, now let's go back in our main header file because we changed the prototype of the add product function. So I'm going to say add product function, return 0 if something goes wrong, or 1 if the product has been added successfully into the list. So here we use the underscore next underscore previous field just to support double linked list. So our product data items can be stored in a linked list. The next step is let's create a function that will search for a product in the list. So search product by name. So search product by name will receive the list and receive the name of the product and then return the product if found or return null. We're going to include the main header file and the prototype will be product. It will return a pointer to a product and the name of the function is search product by name. We pass in the list of product, which is a pointer to a pointer, because okay, someone asked the question. I'm going to get back to that question. So here we have search product by name. And what I'm going to suggest is to just pass in the list, so not a pointer to the list. This is because this function is not going to modify the list, but instead it's just going to read the content of the list. And here we pass in the name, search by name, okay? Now let's go back to the question. What if the cursor is empty and said the if, where is that? The statement here. Yes, if cursor. So this means if cursor is not null, by default, any value that is not 0 or null is converted, let's say, is a true value. So if there is an element in the list, then that means the list isn't empty. We're getting the head of the list. And the cursor, we use that element, let's say the head of the list, and we append, we add in, we connect the new products elements in the list. But in any case, the new product is added, is set as the new head of the list or as the new first element of the list. So if this is null, if cursor is null, then this code is not going to be executed. This means also the new product element is in fact the first element in the list. So that's why we have this if statement. And so if the list isn't empty, cursor would be the first element in the list. And I guess that's it. There is another question, why we did not choose to use single linked list or double linked list. We can use single linked list